What is up, pre-calculus? Let's go ahead and talk about these graphs. Now, this first one you should be best friends with by now. Your old buddy, x squared. Y equals x squared. We all know that this is a parabola, has a point 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. We know that everything is going to be positive above the x-axis because we are squaring it. Anytime you square a number, it will end up positive. If it is negative, it is positive. If it is positive, it is positive. And so we get that thing right there. So let's go ahead and state the domain and range. Remember, domain, we are just talking about what x values can you put into this function, or another way to think about it, what x values can you not put into this function? Well, you can put any real number in and square it and get a real number out. So in set builder notation, we're going to say that x is an element of the set of all real numbers such that x is greater than or equal to 0, which in interval notation we can say x is an element of the interval negative infinity to positive infinity with parentheses, parentheses indicating that we do not include infinity or negative infinity in our answer because you cannot, because it is not a real number per se. Well, let's talk about the range. Well, the range is going to be talking about our y values. So again, set builder notation. We can say that y is an element of the set of all real numbers such that y is greater than or equal to 0. Did you see that silly thing I did up here? I said the range was x greater than or equal to 0. Well, that's clearly not true. I can absolutely square any real number. So what I should have said is just x is an element of all real numbers. There is no condition that we need to put on it, so just leave it like that. Boom. And our range looks good. Y is an element of R such that y is greater than or equal to 0. Alrighty, and then in interval notation, y is an element of the interval. What's that thing you call it? Bracket? Is that parenthesis bracket? Yeah, bracket. Going from 0 to positive infinity. Not inclusive. There you have it. Well, now let's talk about y equals the square root of x, because y equals square root of x is going to be the inverse of x squared. We're still going to have that point 0, 0. We're still going to have that point 1, 1, which will be important later. And now think about the next nice point that we could get. The next nice number we could square is going to correspond to this point, right? We had that. We had that. Now think about that point. On the quadratic x squared, it was 2, 4. On this, it's going to be 4, 2, because the square root of 4 is 2. And we're going to get that graph right there, curving off to the right like that. And so we can say that the domain is now x in the set of real numbers such that x is greater than or equal to 0. Kind of like my mistake last time, but this time it is purposeful. And we will start from 0 and go to infinity, and that is x is an element of that interval. And notice the domain of this is kind of like the range of the last one. That's kind of weird. Well, let's talk about this range here. Now the range on this is going to be the set of numbers y in set of real numbers such that y is greater than or equal to 0. Again, in interval notation, y is an element of the interval 0, infinity, parenthesis. There you have it. Actually, maybe we should talk about that shape briefly. First off, notice that we do not have any negative x values. Pretty much for the same reason why we don't have any negative y values on x squared. You cannot square root a negative number, negative real number anyways, because, well, you cannot square root a negative number and get a real number, I should say, because you cannot square two negative numbers and get a negative number, or square any number and get a negative number. So for that reason, no negative x values there. But why do we only see positive y values? If you think of square root, Normally, you can think of a positive and a negative version of the square root, but if we had both versions of that, hey look, now it's like a sideways parabola. If we had both versions of that, it would fail the vertical line test, so it would not be a function. So in order to make it a function, we only think of the positive square root, not the negative also. So there you have it. It's curving off. It's getting flatter and flatter and flatter because as you square root a number, it's always going to get smaller. And if you think about the square numbers, they get further and further apart.